After every exam takes place, the examiners they publish their own report to give words of wisdom to the students who is going to take the test for the next term. And this is pretty useful in terms of how to get the marks and how to get the maximum mark, how to present your work properly. This is a good idea. So this is the first thing that they write is a general comment of the overview of the paper. Now they said many people they feel that paper 2 might have been harder for some people because they got less marks in paper 2, and this is what happened, and most candidates attempted the questions in both papers in numeric order, although a few chose to work in reverse order. Now, it's a good idea to start from number 1. Some people think if you start from number 10 and then do question number 1, it's a good idea, but it's a good idea uh, if they start from question number 1. They should consider whether this is really advisable, as the earlier questions are intended to be easier to provide a warm up before the harder ones are attempted. So they advise you start from question number 1. Now, that's why the graph paper is at the end, graph sum. So, some candidates seem to rush the question due to this approach. Some people who start from question number 10, they had to rush when they went to the first question. Now, some advice over here. Marks were lost throughout both papers due to failing to round as instructed. Remember, when this is significant figure or decimal places, you have to remember that these are very important concepts that come from Maths B paper 1. There was also a tendency of candidates to give intermediate answers to their calculation to too few significant figures, which led to errors in the final answer. If you're doing step-by-step sum, be careful, because if you don't do the accuracy in one step, you might make mistake in the next step. And square root are used to obtain an intermediate answer, and the square of what the answer is used later. Returning to the original squared value often gives a better final result. Meaning, if you want to working with x squared equals to 30, whenever you get x squared, instead of putting the square root of 30, which is 5 point something, if you put instead of x squared, if you put 30, that would be more accurate. That's some tips about calculation. Most candidates appear to have sufficient time to complete all the works they could do on both the papers. The exceptions seem to be where very complicated methods of solution were attempted to question, or in parts of question where the numbers of marks indicated that a simple solution was expected. Remember, a guidance uh, of the paper is how much mark do you have for something. The fewer the mark, you can do it in a few steps. Don't do it in too much detail. Let's start. The question, this was found to be good opening question. Okay. Question 2. Most candidates started part A well. So part A they did it well, but they had a problem. This is a major problem in quadratic inequality. You cannot write it like this. This is very, very important. So remember, in quadratic inequality, this is one of the major mistakes. And the question was integers. Remember the number line concept. Question number 3. Most candidates knew and could apply the product rule and quotient rule. Errors seen in part included forgetting the 2 or the minus. This is little mistakes, but most people could do this also. Question number 4. I think this was the asymptote. Continues to prove to be problematic. So many people found this to be a problem. So continues to be problematic for some candidates. So uh, you have to pay attention how this works. However, the most frequent mistake was to omit the right hand branch of the curve. Remember, in an asymptote you have to give 2 branches. So question number 5 is many candidates only obtain the acute angle part. Oh, this is, you have to find both the acute angle of the trigonometry 2D question, because the question says 2 possible angles. So this is very, very important. And the next question uses one of the angles for finding the 2D question. Question number 6. Most candidates could form the necessary quadratic equation from the given information to solve it correctly. So everything is fine. In part D, most candidates use the correct formula, so this was not a big deal. Question number 7. Most candidates could make an acceptable attempt in part A and B, with the majority providing a convincing argument for arriving at the printed answer. So question number 7 was, let me check. This is the maximum minimum question. So what we have over here is most candidates approach part D by the second derivative route, and apart from slips in differentiation were mainly successful. So errors in part 2 were due to substitution of incorrect expression. So this is more or less all right. So question number 8, candidates found part A of this question straightforward even if they were then unable to proceed. Only the better candidates could see the connection between part B1 and part A. So remember here, part B1, these are all connected. You have to remember when you do a sum, they follow a story and they're interconnected. And so this should not be a problem. Not all candidates remember to move to equations with integer coefficients. Remember, when you do this alpha beta sum, the answer has to be in integer coefficients. This paper seemed to be straightforward. So question number 9, part A was frequently well done. Although some candidates failed to obtain the given result in part 2 as the better candidates linked part B A to weaker candidates then tended to give up the question attempts to this. So this seems alright. How about the final one? Others either made a reasonable attempt but made a mistake in their working or integrated given function to obtain some multiple of this. So this might be a problem for some candidates, this portion over here, the integration, but otherwise it was pretty easy. It seemed this paper people found it pretty easy. Now, the final one, question number 10. Many candidates factorize the given function, so cubic, they faced no problem, A and B altogether. Part C, but those who obtained a correct equation are almost always successful in part D. It is clearly not possible to know what candidates have added to the diagram in their question, but some of the responses to part E suggested that little attention had been paid to the relative positions of the line. So this is the rule that you have to do. The most efficient method of this area is to use this. So it's a good idea because some people they did it in a more complicated way. It's a good idea to integrate and you use the curve, this one, and then the tangent over here. So that's the suggestion. So this is the overall grade boundary. Of course, paper 1 and paper 2, they're we take the average of that 100, so 200 divided by 2 and we get this. So 81 is a it suggests that it's pretty straightforward. The question was pretty straightforward because 80 or 81 is what we get usually as the grade boundary. So paper 2, it seems that it must have been a little bit more difficult.